Hello, good afternoon. Our topic for today is all about computing the future value of annuity due. So what are the objectives of this lesson? Number one, discuss ordinary annuity due. Number two, determine the formula to be used in solving the future value of an annuity due. Number three, solve the future value of an annuity due. Always remember, be persistent. Soon you will thank yourself for not giving up. What is annuity? It is a series of equal payments at regular intervals. Example of this, payments of insurances, premiums, leases, mortgages, pensions, personal loans, rent, term loans. What is annuity due? It is a type of annuity where the payments are made at the beginning of each interval. Unlike ordinary simple annuity, the payment interval starts at the end of each period. For annuity due, the payments are made at the beginning of each interval. Unlike ordinary simple annuity, the payment interval starts at the end of each period. That is the difference between annuity due and ordinary simple annuity. Future value of an annuity. The sum of compound amount of all payments compounded to the end of the term. What are the keywords to be remembered? We have J, the nominal interest rate. We have M, number of conversion per year. T, time period or term of the loan or investment. N, the number of payments in the annuity. R, it is the size of each annuity payment. Then I is the interest rate per compounding period. We have compounding frequencies and number of periods, compounding or conversion frequency. For annual, we have one number of compoundings or conversion per year. For semi-annually, we have 2. Quarterly, we have 4. Bi-monthly, we have 6. Monthly, we have 12 number of compoundings per year. Let's try to solve this example. How much will Carla Espejo accumulate in her insurance policy by age 60 if the first semi-annual contribution of 10,000 pesos is made on her 28th birthday and the last is made 6 months before her birthday? Assume that her insurance policy earned 11% compounded semi-annually. So this is the example. So these are the formula to be remembered. Annuity due is equal to R multiplied by the quantity of the quantity 1 plus I raised to n plus 1 minus 1 over I minus 1. That is the formula to determine the future value of an annuity due. Annuity due is equal to R multiplied by the quantity of 1 plus I raised to n plus 1 minus 1 over I minus 1. Let's now determine the given and formula to be used to solve the given problem. Again, this is the problem. How much will Carla accumulate in her insurance policy by age 60 if the first semi-annual contribution of 10,000 is made on her 28th birthday and the last is made 6 months before her birthday? Assume that her insurance policy earned 11% compounded semi-annually. What are the given? We have R, size of each annual payment. We have 10,000. Number of compoundings per year is 2 because semi-annual. We have T is equal to 32 years. 60 minus 28, that is 32 years. In order for us to get N, number of payments in the annuity, we have N is equal to number of years multiplied by number of compoundings per year. 32 multiplied by 2, that is 64. J is equal to 11% or 0.11. That is the nominal interest rate. In order for us to get the value for I, we are going to divide J by M. The nominal interest rate divided by the total number of compoundings per year. We have 0.11 divided by 2 because we have 2 number of compoundings per year because it is semi-annually. 0.11 divided by 2 is equal to 0.055 or 0.055. Since we have the values already, let's now determine the formula to be used. That could be annuity due is equal to R multiplied by the quantity of 1 plus I raised to n plus 1 minus 1 over I minus 1. Here are the values, and we are going to substitute these values on the given formula. It goes like this. We have R, that is 10,000. I is 0.055. N is 64 plus 1 minus 1 over I, which is 0.055, then minus 1. What is the first thing to do? We are going to add 1 plus 0.055. That is 1 plus 0.055. The answer is 1.055. 1 plus 0.055, it's 1.055. Then 64 plus 1, we have 65. 64 plus 1, 65. Next step, we are going to simplify 1.055 raised to 65. We are going to simplify 1.055 raised to 65. And the answer is 32.4645865401. 1.055 raised to 65, it is 32.4645865401. The next step, subtract 32.4645865401 by 1, and the answer is 31.4645865401. 32.4645865401 minus 1, it's 31.4645865401. We are going to divide it by 0.055. The answer is 572.0833916. We are going to divide 31.4645865401 by 0.055 minus, then we are going to subtract it by 1. The answer on this part is 572.0833916. After that, we are going to subtract 572.0833916 by 1. 572.0833916 minus 1. The answer is 571.0833916. Subtract 572.0833916 by 1. The answer is 571.0833916. And the final process is to multiply this to 10,000 multiplied by 571.0833916. And the annuity due is 5,710,833.92. This is the final value of the annuity due. 5,710,833.92. Next one, we are going to solve the next problem. Mr. Joseph Carlos made deposits at 900 at the beginning of each month to BPI Cooperative, which pays 12% compounded monthly. After 4 years, he makes no more deposits. How much will he have at the end of the term? And we are going to look for the value of future value of an annuity due. And this is the formula to be used. Annuity due is equal to R multiplied by the quantity of 1 plus I raised to n plus 1 minus 1 over I minus 1. Let's now determine the given and the formula to be used. Here is the problem a while ago. The value for R, that is the number of, that is the size of each or payment, size of each annuity payment, that is 900 pesos. We have total number of compoundings per year, it's 12 because it is monthly. After that, number of years, T is equal to 4 years. In order for us to get the number of payments in the annuity, we are going to divide 12 times 4, that is 48 plus 1. The reason why there's plus 1 because Joseph already made deposit at 900 pesos at the beginning of each month to cooperative, which pays 12% compounded monthly. After 4 years, aside from the deposit 900 pesos, that is 4 times 12, it's 48 plus 1. That's why it's 49. The nominal interest rate is 12% or 0.12. I is equal to J over M. We are going to divide nominal interest rate by the total number of compoundings per year. 0.12 divided by 12, the answer is 0.01. So here are the given. The formula to be used again, annuity due is equal to R multiplied by the quantity of 1 plus I raised to n plus 1 minus 1 over I minus 1. Since we have the given, we can now substitute the given on the formula. It goes like this. We have R, that is 900. The value for I is 0.01. N is 49. Then have plus 1 here. I is 0.01 minus 1. The first step again, we are going to add 1 plus 0.01. That is 1.01. Add 1 plus 0.01. That is 1.01. After that, we are going to simplify 1.01 raised to 50. And the answer is 1.644631822. That is 1.01 raised to 50. The answer is 1.644631822. After we simplify this one, we are going to subtract 1.644631822 minus 1. The answer is 0.644631822. We subtracted this 2, and the answer is 0.644631822. Then we are going to divide it by 0.01. 0.644631822 divided by 0.01. The answer is 64.46318218. Then we are going to subtract 64.46318218 by 1. 64.46318218 minus 1. The answer is 63.46318218. In the final step, we are going to multiply 63.46318218 by 900. And the final answer is 57,116.86. That is the value of the annuity due, or the future value of annuity due after 4 years. Okay, I hope you were able to follow our simple steps for today. Always remember, mathematics will always remind us that in every problem there is a solution. Thank you for watching, and God bless you.